Yeah. I hope all of you are done with installation. Completed. That double click issue sorted out. Control.
But I have that Q&A also in visuals.
You can use a shortcut. Control slash. Double click is not working on this. So I think most of you got some idea like what is Power BI, right? Power BI is a self-service business intelligence tool. Creating a report in Power BI is very, very easy. In few minutes, you can create. But only one challenge is if the data is not so clean, that will take so much time, right? You need to understand the data related issues and fix them one by one. Okay. So today onwards, we'll see the different options in Power BI. But before that, as I mentioned, I'll be doing a revision of SQL because these SQL concepts are needed to learn Power BI as well. Okay. So you need to understand the keys and constraints again, right? So we'll spend some time on keys and constraints. I already took you through the course outline, how it is going to be. Like what is the first step, what is, Power BI, understand it, install it, and, keep the Power BI desktop application ready. And then we get into the get data, how to transform the data using Power Query, how to build the data models, how to write the DAX measures, how to visualize the data with the help of the standard visuals and as well as custom visuals. And then set up the roles and RLS, row level security, and finally publish. So multiple stages are there in our report development. Okay. And it's very, very easy to understand. For each and everything, we have different types of examples with us. So I'll take you through all those topics. Okay. The course outline we discussed and why Power BI, because if you are working in the reporting layer, you need one application, be it XLR, SAP Crystal Reports, SSRS, or maybe Power BI, ClickView, ClickSense, or Tableau, or any kind of a reporting tool that you need. Here we are using Power BI. Most of the scenarios, you will be working with a database. Okay. If it is a very small and mid-scale company, they may give you Excel as a data source, but most of the scenarios you get a database as your data source. It could be any kind of a database. It could be a SQL Server database, Oracle database, Sybase, Teradata, DB2, SAP HANA, whatnot. There are different types of databases available. And you will be using a query language, SQL, structured query language to connect with that and get the required data and create the report in Power BI. Okay, so you may get a question, if I want to connect to the SQL database, SQL Server database, do I really need to learn SQL? Yes, a few commands are definitely recommended, but not everything. Okay, so a few things that you definitely need to understand before connecting to a server to get the database from a database server. Okay, so we'll talk about that one by one. Yeah, so let's move on to the data normalization process. I think for the ones who completed SQL, you already have some idea what is data normalization. So it's a process of splitting a big table into multiple small tables. As a result, we get the dimension tables and fact tables. Dimension tables are the ones they hold categorical data, qualitative data, in other words. Fact tables are the ones they hold numerical data, which is quantitative data. For the calculations, we can use it. That's what we understood. So following the same rules, we are going to, once again, I'm going to explain this data normalization process and why this is needed and what is the schema design and all we need to learn, because when we create our data models, this is very much needed. Okay, so we'll talk about that. So first of all, let me show you a simple example here. Small data set. Okay. Take a look at this. The ones who completed SQL, you already have some idea, but the ones who directly joined Power BI, I want you to actively participate in this, because anyways, the ones who completed SQL, you know this. You have seen this table already, right? If you have joined directly Power BI, My request for you is please answer these things, okay? I hope all of you are good with Excel. Forget about SQL, right? All of you are good with Excel, right? Okay. Let's say if I have a table like this with some data and I want to create a report, total salary by the department name, can I create it? Total salary by the department name, can we create it? Yes? Perfect. Why? Because we have the salary column here and department name column here. And it is possible to use this data to create a summary to show the total salary by the department name. That's easy. And by the way, what is that we need to use if you want to get the output like that? What is the feature of Excel that we use? A pivot table. It's like very easy, right? Perfect. So I want to see the max salary by the job. Can we do that? Max salary by each job. Can we do that? Yes, right? Same. You have the salary column and you have the job column, right? I want to know the count of employees who joined in each year, 2000, 2001, 2002, 2003, and so on. Each year, how many employees joined? Can I do that? Yes, I have the DOJ here. Using that, I can get the year number and a count of employee ID or count of employee name. I can take it so that I can see how many employees joined each year. So that means, all those questions I asked is easy to answer using this single data table, right? But when it comes to the normalized data, let us take a look at this table alone, okay? Only the selected table. I want to find out the total salary paid by the department name. Is it possible? Only the selected table can we create that. Total salary paid by the department name. Is it possible? No, it's not possible. Why it's not possible? Because exactly the department name is not there, but only the department ID is there. Right? Department name is not there, but only the department ID is there. So if you want to get the department name also, what is that we need to do? What is that you do? Correct. We do the VLOOKUP. Perfect. We do the VLOOKUP and we fetch the department name from the departments table. The ones who are good with Excel, you have this idea already how to use the VLOOKUP using this table. And common ID is the department ID, and you can fetch the department name here, something like this, okay? If you want to get the D name here, simply use a VLOOKUP formula. Department ID is this, and table array is this, which is there in the second column and 0, and drag it down. Now, this table, yes, it can be used to generate a summary to show the total salary by the department name. You got the point? Right. So this looks easy if someone knows VLOOKUP. But okay, so let me ask the same question. Let's say if the department name is not there, you have the data located in multiple tables, right? In SQL, what is that you do? You do a join. Perfect. You do a join. The same thing in Power Query, we do a merge. In Power Query, we do a merge. In Power BI desktop, in the data modeling concept, we create a relationship. In Excel, it is a lookup formula. In SQL, it is called a join. In Power Query, it is a merge. In Power BI desktop, it is relationship. So using any of these things, you can fetch the data from the different tables. Again, you get a question here. This data set consists of all the data in one table, right? Why do I need to split this data into multiple tables? And again, what is the point again joining those tables together? Can't I keep all the data in one table? I think the ones who completed SQL, you have some idea about data redundancy. What is data redundancy? If the same values are being repeated for multiple number of times, basically we call it the data is redundant, right? Nothing but if you see here, let's say 20 is there, you can actually write accounts. Okay, 20 is there, accounts, right? So in the place of 20, you can actually write accounts, okay? But the problem here or the challenge here is, as you are repeating this word accounts, accounts, accounts for multiple number of times, it occupies more space, right? A simple example I can tell you here. If I give you a pen and paper and I ask you to write 20 and I ask you to write accounts, okay? Tell me which one takes more time to write? Account. Which one consumes more ink? Accounts. So simple, right? Keep it this way. If you are writing the physical values instead of their codes or keys, they occupy more space and they take more time to store. So in order to reduce this redundancy, what is that we perform? We perform a data normalization. What is the data normalization? Instead of keeping all the data in one place, we split the data into multiple small tables. As a result, you get the dimension tables and fact tables. Dimension tables, we usually write dim. Fact tables, we write fact. Okay, so in the real-time databases, you may find dim underscore, a table name, dim underscore product, which is nothing but a products dimension table. It contains all the details related to the products. Okay, so dimension tables, they hold the categorical data or qualitative data. Okay, fact tables, they hold the numerical data or quantitative data. Understood? Right. As a result, you can get the advantage of that, the space, the storage space, whatever it is there, you can minimize it. Okay, the usage of the space, you can minimize it. Right. So that is the advantage by doing data normalization. As we are working with the keys can be indexed. Nothing but if you are using the primary keys, foreign keys. Okay. So these are keys only here. This 10, 20, 30, 10, 20, 30 are the keys only. This employee ID is also a key only. Key is nothing but a kind of a code, a uniquely identifiable code. Okay. You can call it a key in the SQL, terminology. You can call it a key. What is a key? A key is a code. Okay, to identify something uniquely. Okay. So here we have the different keys. Employee keys are there, job ID keys are there, department ID keys are there, right? Gender ID keys are there. So different keys are there. Right. We need to understand now how this data can be joined together. Okay, let me keep it very, very simple now. If I'm looking at job ID 1, can you tell me what is job ID 1? Which designation is it? Which designation is it? It's a excellent. It's manager. How did you figure this out? How do you know that it is manager? Because this job ID, you are looking up that value here in the job ID table, jobs table or the designation table. Understood? Right. So how about this? If I want to find out what is department 10, how do we do that? Which one is it? Which one is department 10? HRD, excellent. How did you do that? How did you figure this out? Very simple. Again, you are looking at, right, the department table like this. Okay. What is gender? Let's say gender 2, male employees, right? So how, again, you are looking up this value here. So same thing. So that means each and every table, right? They have the keys here in this example, right? And you are able to find that key, other, the corresponding value or the associated value here in the next columns. And the same thing we do in Excel with the help of a VLOOKUP or XLOOKUP or index match or something like that. In SQL, we do joins. In Power Query, we do merge. In Power BI, we do, in the data model, we do a relationship. Remember these terms, okay? Fine then. Now you understand, right? So these keys help us to gather the data into a single table if needed with the help of lookups or joins or whatever. Right, perfect. And you also understood why we split the data into multiple tables. Instead of repeating the same physical values, we simply assign a key. Instead of writing a manager, we simply put one there. One represents what? Manager, right? Perfect then. So here's the one. By storing the data like this, we can speed up the data retrieval, okay? Because it occupies less space and it can be indexed. In this process, the keys are the ones they play a crucial role. Keys. I want you to remember these two words, primary key and a foreign key, right? Primary key and a foreign key. So what is a primary key and what is a foreign key? Let's keep it simple. First of all, let us talk about only primary key. What is a primary key? Primary key is something that is unique and not null. Remember the two properties it needs to satisfy, unique and not null. So if something is there that is unique and not null, you can consider that as a primary key. So let us talk about a few examples of a primary key now. Usually, if you are looking at the employee table, employee ID is a primary key. Why employee ID is a primary key? Because each and every employee gets one uniquely identified or identifying number, right? So unique identification number every employee gets. So that is one primary key, right? Let's say student ID. Student ID in the student admissions table, the student ID is assigned, right? So that is also a primary key to uniquely identify the student. Right. So understand that you see these kind of keys in many places, right? These kind of keys are there everywhere, almost everywhere, right? Even if you go to the metro pillars, each and every pillar has one key, one primary key there to uniquely identify that pillar number. So in couple of cases, I found something interesting there. Usually we have like ABCD series pillars, okay? So that the first character, first alphabet tells you the root. The second number that tells you the pillar position. The roots are divided into ABCD tracks. Okay. So here we go. If, even I got it out, if a pillar number is incorrectly mentioned, let's say A1060, A1060, two pillars have the same number. I got it out like how would they manage it? Usually, that shouldn't be the case actually, but how would they manage it? But I found in one of those pillars, they had to put A and B at the end again. Why? Because a pillar can't be duplicated. Because that asset allocation and the materials applied to that pillar and all, everything needs to be again tracked. Right? A pillar number can't be duplicated. So if you observe, I don't exactly remember, but it happened in Hyderabad Metro pillars only. So if you, I don't know what which route it was, but they had to mention A and B at the end to differentiate both the pillars. But the pillar number is same. Something like 1060A, 1060B. Right? The first character is there, C1060A, C1060B. Why they had to do it? Simple. Every pillar needs to be identified uniquely. Right? Sometimes it happens, okay? Even though you take so many precautions to give a unique number, sometimes, something goes wrong and they may need to give a number like this, right? Invoice numbers also sometimes we uploaded an incorrect invoice number into a GST portal, okay? So that was duplicated actually. Two clients we gave the same invoice number. Then they requested us to put a and B at the end. So there is a provision for it actually, even if something gets duplicated, right? So I hope you understand the importance of why things to be identified uniquely, right? Everywhere, every place, okay? Even if you look at in a few places, just, start observing these things. You go to a bank, right? On their computer monitor and all, there will be stickers. First code, let's say ICICI Bank, let's say, ICICI 0183 something slash 001 slash 002, something like that. So that means, in that branch, in the desk, on the desk number so and so, this is the monitor number. You just observe that everything has one uniquely identified, identification number, a unique identification number. Okay. So I think you see so many these kind of things, right? So everywhere, if you take a bill, if you go to a restaurant and you get a bill, there will be an ID on it. Go to a shop, you go to shopping and you buy something and you get a bill, there will be some number on it, transaction ID something, right? Everywhere these things are uniquely tracked, right? So many things. Let's say laptop serial number, right? Student admission number, vehicle registration number, right? For everything. Look at this. If you go by metro, you will see each and every coach has one unique identification number inside, the coach number, right? If there is any complaint, you can raise, you can WhatsApp us this complaint and so on. So, they mention one unique identification number there. Start observing all these things. Everything in this world, if it is connected to anything like a database, it should have one unique identification number, right? As a citizen of India, what is the unique identification number for us? Aadhaar, right? How about PAN? PAN can't be PAN. So to say citizen of India, PAN, is it needed? PAN. Is it needed to say we are citizens of India? Then almost 95% of this Indian population will have to leave the country then. Everyone has PAN. In this room, everyone has PAN. No, so PAN is applicable only for the ones who go for the tax, filing and all. Not for everyone. But when it comes to Aadhaar, Aadhaar is for every citizen of India, right? Voter ID, every citizen of India. No, again, there are rules, right? 18 years must be full, right, to exercise the voting. Understand? So certain things are there. They are IDs only, but only thing is that not applicable for everyone. Okay, but Aadhaar is a identification number for every citizen of India. Something like SSN in USA, Social Security Number. Right, in many other places also they use SSN only. Right, okay, fine then. So I hope you understood why these primary keys are needed. Right, to uniquely identify each and everything. If it is connected to any kind of a database, definitely there will be one unique identification number. Right, okay. Employee ID, is it a primary key? Yes, it sounds like a primary key. Right? For the ones who completed SQL, you have some idea already. Employee ID, not every time it's a primary key. You know that. But let us show it to others also why it can't be a primary key every time. I hope you understood the concept of this, the data normalization and how the data can be brought together into a single result set using those keys only. Right? I'll just minimize it. Let's talk about a primary key and then we'll get some idea here. Yeah, here we go. If you look at this table, something that can be uniquely identified, right? And I want you to tell me which column is a primary key column. I want online participants use the chat window to respond to this question. What is the primary key? In this? Okay, online participants use the chat window to answer this, please. Excellent, I'm getting it. Table pay ID, pay ID, pay ID. Okay, looks like everyone is saying pay ID. Okay. No one says employee ID. So this tells me clearly, I think the ones who completed SQL, they are only responding to this question. So others are just keeping quiet. They want to just see what is the answer and then probably basis on that they will respond. Okay. Fine then. Yes, pay ID is a primary key here. And with this example, you all will be able to easily understand why sometimes, a key, let's say employee ID cannot be a primary key. Very simple. What is a primary key? We discussed already. A primary key is unique and can't be null. So these are the two rules a primary key needs to satisfy. If you look at the current screen, you see both pay ID and employee ID are looking unique and not null, right? And none of these things have a null value. So everything has one value and each and everything is unique only. But understand one very, 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 very important thing. Whenever you want to call something as a primary key, first of all, you need to know the table name. Know the table name first. Why do I need to know the table name first? Okay, here we go. If I'm looking at the payroll table, which means it is employee payroll table, every month a payroll needs to be generated for all these employees, right? You need to know the table name first. If it is a payroll table, If 1, 2, 3, 4 employee is paid in the month of May, the same 1, 2, 3, 4 employee must be paid in the next month also, right? You understand? So that means the same 1, 2, 3, 4 will be repeated once again here. Right? So what is a primary key? That is unique and not null, right? So if this is getting duplicated, if you mark employee ID as a primary key in this table, you know what is the challenge there? Every employee gets paid only once for the entire career, right? I already suggested all the SQL batch students, don't join that company. Understand, right? Why? Because you will be paid only once for your entire career. You work there, you will be paid only once. Why? Because the system won't allow the same ID to be repeated in that column, right? If you mark this as a primary key, it must stay as unique only. So that is the reason in this table it is not a primary key. Employee ID is not a primary key. Which one is a primary key? Pay ID is a primary key. Pay ID is a primary key. Why? Because every pay ID is uniquely generated for all the employees, and next month it will generate new pay IDs. But the same employees only to be paid, right? Every month. May paid, June paid, July paid, August paid, and so on. You understand the point? Okay, so in this table, pay ID is a primary key because something that is unique and not null, it is satisfying the rule. But how about this employee ID is also something sounding like a key only, right? Yes, it is a key, but it is called a foreign key. Why do I call this as a foreign key? Because a foreign key, what is a foreign key? Now let's try to understand. A foreign key is it is a primary key of some other table. What is a foreign key? A foreign key is a primary key of some other table. So if you take an look at this employee ID, employee table employee ID is a primary key. So here it is acting as a primary key. The same primary key acts as a foreign key in the payroll table. There is a reason why we enforce this kind of a relationship, because a simple thing, data integrity. Let's say if I want to make a payment to 9999 employee ID is 9999. I can't make this payment. No, I can't make this payment. You know why? Because there is a foreign key constraint applied on this. It checks its original table where all the primary keys are listed. Do we have any 9999 key here? No. So that means you can't make the salary payment to this employee. So simple. If an employee who is not present in the employee table cannot be paid in the payroll table. Simple rule, right? So this will help us to maintain the data integrity, right? If employee ID itself is not there in the employee table, then how can you make the payment? You understand? If the hall ticket number itself is not there in the hall tickets table, then how can you write an exam? You understand the point? Right. So these kind of, things are easily, solved or resolved using the primary key and foreign key. You cannot have any number which is not present in your primary key table. Understand? Right. Simple thing. Let's say you bought a product. Okay. Sometimes these things happen. Okay. You buy a product, you go to a shop, you buy a product. Okay. You get a bill. Scan it, I gave you a bill. And when you checked and the product isn't good and you wanted to return it, okay, and you go back, and what is it they ask? They ask for the bill copy. And when you give the bill, right, when they, again, let's say if the barcode is there, if they scan it, right, if that barcode is present in their system, it will automatically pull the details of that product, right? Just in case if the barcode is not read correctly, then they say that no, you did not buy this product from us, right? Sometimes, let's say you did shopping in both two different shops, but you actually need to return one product to a different shop, but you carried a different product. And when they scan it, they simply say that, okay, this is not present in our database. You're getting the point? So that means, a simple thing, if something is not present in their catalog, they cannot take a return, right? The other words is, let's say, if you are trying to buy something, let's say you pick up a product and you go there to the counter and they scan it and it's not getting scanned. Can they sell it? No, simple. A product that is not there, they cannot sell it. right? But physically the product is present, right? Yeah, I understand the physically the product is present, but if the barcode on that, tag, if it is not read, they cannot sell it. It's as simple as that. What they usually ask is that, okay, get a similar kind of a product, right? That has a barcode that can be read. You get the point? So the keys play a very, very major role like this. Understood? Okay, got some idea, right? So what is a primary key? This is what you always need to check. If a question comes, okay, something like EMP ID, okay, EMP ID, is it a primary key? You know what is the correct answer? Exactly in which table? Answer itself is a question here. Because without knowing the table name, you cannot say something is a primary key. Aadhaar number, is it a primary key? Which table? Perfect. Aadhaar issuing authority, primary key, because they issue the ones. Vehicle registration number, is it a primary key? In which table? RTA, who issues the vehicle numbers? Primary key. They issue each and every vehicle with one unique identification number. Student ID, is it a primary key? Which table? Student admissions table. Primary key. Each and every student gets one uniquely identifiable number there, right? But the same student ID in the examinations table, foreign key. Why? Because the same student needs to attend the exam with the same student ID. Understood? Right? With that, you got some idea what is the primary key, foreign key? Do not check or do not think like, okay, something that is sounding unique. Don't say something is, always a primary key. No, you never know that. Because unless you know the table name, you can't say whether it is a primary key or a foreign key. Understood? Got some idea now? Right. Laptop serial number. Which tables? Laptop manufacturing table. Primary key. Perfect. But the same laptop serial number or the same laptop can go to the service center for multiple number of times. Right? In the service center table, it is a foreign key. Understood? Got some idea, right? Excellent. So online participants, is this clear? Please mention in the chat window if you're okay with this so far. Okay. So with that, we understood what is the primary key, foreign key. So let us discuss let me just repeat it as a summary once. So we understood there is something called data normalization. As a result, we get multiple tables. And these tables data can be brought together using the keys only. So in this process, we understood there are two types of tables, which is a dimension table and a fact table. Dimension tables, they hold qualitative data, categorical data. Okay. So in the fact tables, we see numerical data, quantitative data, something that can be used for the calculations. Usually in the dimension tables only, you see the primary keys. Primary keys. If you observe in this model also, all the primary keys are located in dimension tables only. So this is a dimension table, department table, this is a dimension table, this is a dimension table. Then what is a fact table? How to identify that? A fact table that holds the numerical data. Then you get a question, this is also holding the numerical data only, right? Why are you not calling as a fact table? Very simple, you should be able to do the sum. If you can do the sum and if the result makes sense, yes, then you can call it a fact table. But you tell me this 150, does it really make any sense? If I do the sum of department ID in this 150, does it make sense? No, it doesn't make any sense. Right? Similarly, the job ID also, if I do the sum, does it make any sense? No. If I do the sum of any of these columns in this table, do you see any column that allows you to do the sum? Which one? Excellent. Salary is the one. If I do the sum of this column, yes, it makes sense. Right? So that's the reason we call it fact table. Right? And this is a dimension table. Right? So the ones who completed SQL, you may be getting it out like, why do I need to once again learn all these things? I already have some idea, right? Okay, hold on. This is the point. Whatever you learned in SQL, we are going to use the same concepts while building the data models in Power BI. Right? For the ones who join directly, they also need to know what is the primary key, foreign key, right? So that's the reason I'm repeating this, but it is something like a refresher for you, all of you. Right, dimension tables and fact tables. Dimension tables, they hold only the qualitative data using which you can't do any calculations. Fact tables are the ones they hold the numerical data, quantitative data, and using which you can do the calculations, right? Fine then. So at least one column allows you to do the sum of that. And if the result makes sense, you consider that as a fact table. Easy definition. You take any one of those columns and you do the sum and the result makes sense, consider that as fact table. Done? Easy to understand? Okay. I'll show you an example using the W3 schools only. And you tell me okay. So tell me, is it a dimension table or is it a dimension table? How do you know? So everything is something like a categorical data only, right? No quantitative data there. But I get a question, postal code is there, right? I see numbers, can't I do the sum? No, doing the sum of the postal code doesn't make any sense. Okay, customer ID is there, right? So we have the numbers, can't I do the sum? No, doing the customer ID sum doesn't make any sense, right? So it is, yes, it is a dimension table only. Okay, let me show you the categories table. Okay, tell me, is it a dimension table? This is also a dimension table only, right? Only the categories related data it has. Right, okay. Employees. Yeah. What do you think? It's a dimension. Okay, excellent. Order details. How do you know? Excellent. Yeah, quantity column is there. Quantity can be summed up, useful for the calculations. Yes, you can consider this as a factor, right? Orders. As it is a dimension table because we don't have any column that can be used to do the sum. Yeah. Products. Products, what is it? Fact table or a dimension table?
Fact table.
Okay. Fact table or a dimension table. Okay, here we go. How many of you are thinking it is a dimension table? Raise your hands. None of you. Okay, everyone says it is a fact table. Right. Why it is a fact table? Why do you think it is a fact table? Because price is there. Okay, cool there. Price is there. I told you a simple thing, right? You should be able to do the sum. Then only it's a fact table. Okay, tell me something. Different products are there and different prices are there. Can you do the sum of those prices? Does it make sense? So you know what is it you're doing? You go to a restaurant, you take a menu card. What is it you see there? Chicken biryani, mutton biryani. No, right? Okay, here we go. You see a table there. In the restaurant menu card, what is it you see? You see a table there, right? With the product item code, item description, and the item price, right? You know, what did you do just now? You did a sum of all the product prices on the menu card. Does it really make any sense? No. Do we do that? No, right? There is no point doing a sum of all the product prices, right? That are there on the menu card. It is something like a menu of the different products and different prices. Do we need to do the sum? Or even if you try to do the sum, does it make any sense? No. Just because something is looking like money value, don't say it is a fact table. Okay, not every table is a fact table, even it contains some numerical values or the money values. It is a dimension table only. You cannot do the sum of this column. But you can turn this dimension into a measure. How? If you multiply this price with quantity, that's when it becomes a measure. Simple. When you order something, let's say, there is a 100 rupees product in the restaurant menu card and you order two things, okay, two quantity. So 100 multiplies 2 is equal to 200 is a sale value. Sale value, yes, it is a measure, but not the price. Understand? Price is not a measure. You cannot do the sum of that column. Understand? Just because something looking like money value, you cannot say it is a measure or a fact table. Understood? Got some idea now? Okay, perfect then. Product shippers, suppliers, all this, I think you can easily figure this out. How many fact tables are there in this? Out of all those things, we saw only one fact table, which is order details table. Rest everything like products, categories, customers, everything is like a dimension table only, right? And these things are connected together using what? Keys. What type of keys that we discussed? Primary key and a foreign key. Okay, so let me ask you these questions now. If I take the customers table, okay, customers table, which one is a primary key? I want you to identify the primary key now. Which one? Customer ID is a primary key. Excellent. If I look at the categories table, which one is the primary key here? Category ID. Excellent. If I look at the products table, which one is the primary key here? Product ID. But I also see the category ID. So category ID in the products table is foreign key. Excellent. Why? Because this category ID in the categories table is a primary key. The same category ID plays as a foreign key role here. Understood? Okay, here we go. Order details table. Which one is a primary key here? Order detail ID. Okay, I see the order ID also, right? Order ID, can't this be a primary key in this table? Definitely no. Why? Because 10248 is repeated for multiple number of times, but the same order ID in the orders table, 10248 is primary key. You know why orders table order ID is repeated for multiple number of times in the order details table? Very simple. If you place an order, you place an order with multiple line items. Order number remains same, but within that order, you will have multiple line items, right? So here in the order 10248 ID, right, 3 items are placed, 1, 2, 3 IDs, okay? Row IDs are the detail ID. In that, product ID 11 was ordered, 42 and 72 were also ordered. Okay, understood now? Okay, so you need to understand one more very important thing. After performing the data normalization, we see 2 types of schema designs. Okay, we already discussed that as part of SQL. What are they? Star schema and a snowflake schema. So let me show you a star schema. Star schema is the one, it is the ideal one for any kind of a report in Power BI data model. Also, we prefer to have our data in the star schema model only. Why? Because it's very easy to report. Okay, a simple thing here. I think you know what is a dimension table and what is a fact table, right? Yes. Why do I call this as a dimension table? Because they hold what? Categorical data. So if you look at the products table is definitely a dimension table. Why? Right, all the product related information is stored there. Product ID, product price, product model, product name and all that, right? Okay, so here we go. I have a fact table. Which one is it? It's a revenue table. How do you know that? Or what is that one thing that is helping us to identify this as a fact table? Or one thing or two things? What are they? Right, unit sold is there, nothing but quantity, and there is one more column also, revenue. Revenue is a numerical column only. So because of these 2 columns only, we call it as a fact table, because using these 2, I can do the calculations. Fact table. But if you look at the all other dimension tables, you don't have any numbers that can be useful for the calculations. Understood? Right, here we go. Whenever you are working like this, okay, a fact table is connected to multiple dimensions like this, okay, we call it as a star schema. Why do I call it a star schema? No, it looks like a star, but you get a question like, a star must be like, with the 5, what is that, 5 points, right? Don't think it should be always with the 5 points or something. It's something looks like this, like a star, okay? So that means in the middle you have the fact table, and that is connected to multiple dimension tables like this. Okay, understood? Okay, fine then. So if I want you to report something, okay, if I want you to create a report using, okay, something like this, I want to see the total units sold by the model. Can we do that? Model ID. Yes, we can. You guys in the products table, you have the model ID and units sold. Total revenue per month. Can we do that? Yes, revenue and month is here. Okay. So total revenue by the dealer name. Yes, revenue and dealer name. Right? And total units sold by the country. Okay, units sold and the country. So this is very easy. If the data or the model is created using a star schema model, then fetching the data is very easy. Because the fact table is directly connected to multiple dimension tables and it looks like a star. Okay, where the fact table is in the center and all the dimension tables are in the surroundings. And directly connected to the fact table using those primary keys and foreign keys only. I have a question here. Products table product ID is, okay, product table, actually it should be a product ID, but okay. Let me take this. Branch table branch ID is, what is it? Branch table branch ID is, yes, it's a primary key. The same branch ID in the revenue table is correct. It is a foreign key. I hope you understood why something is a primary key and why something is a foreign key. Right? So we build the entire data model using these concepts only. Right? So what is this called? This is a star schema design. This is a star schema design. Let's see the next one. It is a snowflake schema. So why do we call this as a snowflake schema? Because you have one fact table that has dimension tables and that dimension table has sub-dimensional tables. Okay, this is a snowflake schema. Right? A fact table is connected to a dimension table and that dimension table is connected to further, sub-dimensional tables. Okay, I'll tell you why. I'll tell you why the snowflake schema we try to avoid and we try to bring the data as a star schema only. Why? I'll tell you. Why it will take time, I'll tell you that as well. If I want to find out, the dealer-wise total revenue we got, dealer-wise. Okay? Dealer-wise total revenue, if you want to find out, you just need the dealer name and the total revenue. These two things can be part of my output. Right? Dealer name and the total revenue. That is easy. Okay, these two columns. This column and this column. Done. But what if the country, what if the business asks like, we want to see the country, dealer country and the total revenue. You see this now. The requirement is like this. You want to get the revenue by the dealer country. Okay, dealer country is here and revenue is here. Nothing but this column should come into your output and this column should come into your output. Right? So these two columns should be there in your output. So here's the catch. Here's the problem. You cannot directly link the fact table, revenue table with the country table because you don't have any direct key available between them. So what is it you need to do? You need to go with dealer ID to dealer ID and dealer country ID to dealer country ID. This is how you need to build a relationship so that the data flow will data flows from this table to this table and this table to this table. And from here, I can fetch the country name and from here, I can get the total revenue. Right? So as you need to take a route like this between this table and this table, you have another table. You need to go via that table and then go to this table to fetch the required data. This will take some time. Okay. Sometimes the requirement may be like this also. You want to find out the total units sold by the fuel type. You have like different fuel types. You have petrol, you have diesel, you have hybrid, you have electric, you have CNG, 5 different fuel types. And business asks like, okay, can you find out, we need to figure out like how the different types of vehicles, quantity we are able to sell. So that means one column is coming from the revenue table, one column is coming from the variant table, and from this you want to get an output, right? The total units sold by the fuel type. Okay, each fuel type, how many units we sold. You understand? Right? So from here, model ID to model ID, you need to go there. And then model ID to model ID, this has a variant ID to variant ID, you need to go there and then fetch these two columns. Right? We try to avoid the snowflake. Why? Because where if you have more number of tables, it takes more time to fetch the data. But sometimes you can't avoid it also. You will have to design the snowflake schema designer. Okay. We try our best to merge these two tables into this dimension table. There is a concept called merging. Instead of keeping these two additional tables, what is that we do? We simply merge that into this table. Dimension table to dimension table merging is okay. So these two are dimension tables and we'll be merging these two columns also. Okay, 1, 2, 3, 4, right? So here anyways, the location ID is there and country ID is there. Region and the country name, we will try to merge these two columns into this table itself. Okay, we don't need additional tables. Okay, so that in one table itself, you will have all the required data. Country-wise or location-wise analysis, you can easily do after merging. But if it is there with multiple tables, definitely we'll have to create a relationship to read the data from the other table. So more number of tables if you create like this, let's assume that this variant has one more table, right? So this variant has one more table and that table has one more table like this. If the business asks, we want to see a field from here and a field from here, right? So this will take so long time. Why? Because this needs to talk to this table, this needs to talk to this table, this needs to talk to this table, and finally this field. Not a great idea. Okay, so Snowflake we try to avoid, or otherwise at least we try to bring the data as close as possible so that the report runs faster. Okay, more number of tables involved, then obviously it takes more time. Right, the ones who completed SQL, you already have some idea what is the Snowflake schema, what is the star schema. In the data modeling concepts of Power BI, we talk more about this. Okay, done. Is it fine? You understood? Now you know the two types of schema designs, right? A Snowflake schema and a star schema. Star schema is something that looks like this, and Snowflake schema will have a dimension table, and further it will have one subdimensional table as well. Done. Okay, perfect then. So why do we get into this kind of a situation? Because of the data normalization only. The more normalization will result, more number of tables, right? But you get an idea that why do I need to do a data normalization if everything is there here? It is easy, right? Denormalized data set easy, right? Let me ask you this question. As a data analyst or a reporting analyst, what kind of data design or the model that you like to work? Is it a denormalized model or a normalized model? Denormalized. Why do you like to work with denormalized data? Because everything is there in one table itself. Then it is easy for you to, create the report, summaries, pivot tables, charts, everything. But if it is normalized, then you need to use lookup formulas or joins or relationships to get the data. But the thing is, in the real time, almost all the data sets are normalized data sets only. It's very, very rare that you get a denormalized data. Understood? Perfect. Online participants, any questions? Use the chat window to respond, or you can unmute yourself and respond. Okay. Employee ID, is it a primary key? Which table? Excellent. Aadhaar? Which table? Perfect. So without knowing the table name, you cannot say something is a primary key or not. Right? You also understood what is a star schema design and a snowflake schema design, right? Which one is recommended for the better report performance? Star schema runs faster. Okay, in our data model also we try to create the star schemas only. Right. So this is what we discussed yesterday, right? One of those slides that shows the stages in the report building, developing a report. Right, here we go. Developing a report in Power BI desktop. We start with get data. So this is our first step, get the data and transform it. Okay. I'd like to show you one data set today, and you need to tell me whether it is a normalized data or denormalized data. Okay. Let us focus only on the get data, data modeling and all. They are our next steps. We'll go there. So let us complete our first step. Get data. I want to use this Excel data. Today, I want you to create one small report using Power BI desktop. I hope all of you are done with the installation. If not done, try to do it today. And you can watch yesterday's video. And in that, I explained how you can download Power BI desktop. It's easy process, only hardly takes any half an hour to install it. Right. So I want you to take a look at this data, right, and find out whether it is denormalized data or normalized data. You can I think you can easily answer this. So we have the customer ID, customer name, segment, country, city, requirement, state, postal code, region, product ID, product category, subcategory, product name, sales quantity, discount, profit. Okay, all the columns are there. Tell me, is it normalized data, denormalized data? This is denormalized data. Excellent. Why? Because the simple thing I'll tell you, if customer ID is there, I don't really need to maintain the rest of the columns. I don't need the customer name, segment, country, and the rest of the things. Why? Because the customer name, customer ID is there, using which I can fetch the name, I can fetch the country, I can fetch the region, I can fetch the segment and city, all other columns. But in this table, everything is there in one place. If everything is there in one place, what kind of data is it? Denormalized data. Okay, here we go. You have how many sheets here? Excel sheets, right? How many sheets you have? 5 sheets. Excellent. I have the question here. You got 5 sheets here. Tell me, is it a table or a normal range? Is it a table or a normal range? It's a table. Perfect. How do you know it's a table? Table design. We discussed this point. Almost 3 to 4 questions are there in MOS exam on the table design only. Okay, how to identify something is a table? Table design. Okay, perfect. Customers, is it a table? No? Okay, how do you know it's not a table? Yeah, there is no table design. Products, if you keep the cursor, is it showing the table design? No. Transactions? No, it's not a table. People? No, it's not a table. It's very easy to identify something is a table. If you keep the cursor on the table, if you see the table design, then only it's a table. Otherwise, it's not a table. Right? So what is the table name? Orders table. Okay. I want you to create your first report like this. The one that I created yesterday. I want you to do the same thing. Today, I'll take you through step by step. Open Power BI, pick up a blank report. Right? You want to get the data. So what is your data source? Excel. Excel is our data source. It's here. Okay, you can get the data from Excel from here, from here, from here. Or if you go to more, the very first source is Excel only. I got a question, why Excel only? Why Excel only at the top? Most commonly used. Right? So I'll connect to Excel file. Which one is it? It's there in the data sources folder. I hope all of you got the material package. If not, check with the front office and they'll share the folder, Google Drive folder with you and download it. And I want you to create this report and share the screenshots in our permanent group. Okay, B00725 permanent Power BI group. Okay, select this and I'll be surprised to see how many sheets we found. 5 sheets, right? But how many objects you have here? Count them. How many? Got 6. Can you find out why we got 6 there? Here we go. This is a table icon. This icon is a table icon. What is the table name? RS table. This is a table icon. Right? All these things are sheets. How do I know they are sheets? Observe here. There are sheet tabs, two tabs. There are small icons there. Excel workbooks, they look like this only, right? With the sheets at the bottom. All these things are what? Sheets only. Now you know what is a table and what is a sheet. And it is always recommended to go with the table only. But that's okay. Sometimes we go with sheets also. But recommendation is go with tables, right? So tables are the ones, okay, table is the one now I'm going to use to complete this exercise. Right, select this table. You have 3 options here: load, transform, cancel. Load is nothing but load the entire data into Power BI. Transform is to perform the different transformations, the data cleanup. Okay, you can clean the data, you can remove the columns, you can filter the data, you can replace the values, you can fill down the values, and so many things you can do as part of the data transformation. But now I'm not doing any transformation because it's like a cleaned table only. I just want to load all the table data into Power BI without any transformation. Right? We have cancel here. If you don't want, you can cancel that. And if you click load here, this orders table will be loaded into Power BI. Done. So all the data that is located in the Excel, you got it here into your Power BI, right? I want you to do something like this, right? Either you can use a control / for the Q&A visuals, or you can just do a double click to enable the Q&A visual. Control / you can do, that is / is just next to the dot with the full stop. Okay, control / you can do, or double click you can do, anything you can do. Okay, or otherwise you can directly go to a Q&A visual here and you can take it. That is the third way. So I want you to build your first Power BI report, okay, with this sample data set like this. Shouldn't take much time. Yesterday I created the same thing, but without explanation. Today I'll explain what is it I'm doing. Just do a double click here. And I want to first of all find out the total sales. Okay, just total sales. And you get that value. Here's the one. It is currently a Q&A visual, because Q&A is enabled here. You observe this, right? What you want to do is, you want to turn this into a standard visual. You have a button here. Just click that button so that it turns into a standard visual. It is showing what sum of sales. By the way, reading this number is very, very difficult because it's such a lengthy number. I'll do one thing. After turning this into a standard visual, I'll go to the format visual, and you have here call out value. And the display units, I want to set it to auto. Nothing but it turns this value into millions, billions, and all, right? Automatically, like this. Like this. You see that 21.83 million, right? So let us copy this and paste this. You can do that. And you can just turn this into any other kind of a visual. Okay, I mean to say like any other number you can show here, copy pasting. Right? And you can uncheck this, I mean, delete this or remove this field. And if you check this profit, you see that? You just need to check. But you get a question, can't I do this total profit also with the help of Q&A? Yes, you can do that. How do you do that? Again, let me just do remove this. Just do a double click there, ask total profit, right? Yeah, it is currently a Q&A visual. Again, turn this into a standard visual so that it will turn into a card visual. You see that the card is now activated. Right, this card, same thing. I want to set the call out value display units as auto, same thing. And I want to get the total quantity, same thing here. Total quantity, just ask the question and turn this into a standard visual. Done? Right. I want to see a chart here, which is something like this. I want to ask a question, total sales by state. Usually when you ask this kind of a question, it creates a standard bar chart. You can ask it, okay, in a column or a map. That's it. I want it to be like a map chart only. Turn this into a standard visual. Currently it is a Q&A visual. And once I click on the standard visual, this map will be enabled. Observe this. Now it has turned to a map visual. And again, just do a double click here. I want to create total sales by category. Okay. Turn this into a standard visual. And total sales by segment. Okay, in column chart. Turn this into a standard visual. I want a couple of slicers here. There are different types of slicers. You know, earlier you have got like a button slicer, you have a text slicer, you have a list slicer, right? Different kind of things. But let's go with the normal slicer. In this slicer, I want to use something like a region. Copy paste that. You can do a simple copy paste, Control C, Control V, okay? And in here, I want to say the segment. That's it. So if you are selecting something here, all your charts will respond. All numbers will respond. Finally, one title. I want to name it as something like sales report, a sales performance report. So I did the same thing yesterday. Right? You can see Florida, how is it? California, how is it? Texas, how is it? So I want to see a screenshot from you like this. You may want to apply different colors also. It's up to you. If you want to apply the different colors, you can do something like this. You can go to the view at this point. You can just choose any of these things, okay? Different things. Okay. Can you all do this? Yes. Perfect then. So do this and share the screenshot in the group itself. I want to see this, your first report. Just select a couple of things and see how the numbers are getting dynamically updated there. Okay, filtered there. And all these things are interactive visuals. You can click on any of these visuals, okay, to filter the data. Right? Apply different kind of formats there. It's up to you. Okay. Done. So can you all create this? Yes. Just arrange these objects carefully. That it looks good. Okay. Fine then, this is what you need to create today. Okay. Online participants, is it okay? Can you all create this? Please confirm in the chat window.
Yes.
Right, okay. So it shouldn't take much time, but as you're a beginner with Power BI, you may be confused and sometimes you may load some wrong data or something. But for now, it's okay. Even if you do any kind of a mistake, it's okay. I just want to see how many of you are actively participating. So I definitely need you to share the screenshot in the group. Done? Right, okay. So any questions from today's session? I hope all of you are ready with your Power BI desktop application. If not, yesterday I explained the same thing. Go to the Microsoft Start button, Windows Start button, and search for Microsoft Store. Open that. And in here, you need to search for Power BI Desktop. Okay, just go there, get it. Okay, for me, it is showing in open because it's been already installed, right? Done. Questions? Okay, fine then. So let's catch up tomorrow. Please make sure you complete this and submit it by today evening itself, right? Great, yeah, requesting you to reach out to the front office, get the material first because all the material files, whatever I'm using, it's there. And also I hope you got the access to the videos and the Google Drive and all other required stuff. And you should be part of permanent P B00725. It's not T, not the temp one. Because I'm going to post all those requirements and all in the permanent group only. So make sure you are there in the permanent group. All right. Great, then. So thanks for attending today, and let's catch up tomorrow and requesting you to complete this exercise. Okay. Bye, everyone.